Hi there, my name's Jamthe, and I'm absolutely privileged to be asked to return this year for the IoTDay Women on the 9th of April 2022. I am going to be presenting today some key concepts and ideas behind what we mean by natural language processing. I'm just going to introduce myself now and just give you a general overview of what we're going to talk about. So my background is that I am a teacher. I've got quite a few years experience working in high schools, and I've previously taught in university as an associate lecturer. And I'm a founder of an organization called Girls and Boys in Tech and the Language School, which was and is an organization that focuses on delivering STEM and language training and tutoring to underrepresented groups. It's also an organization where I'm developing EdTech applications as well, particularly for education and for young people in a range of different subjects to support them in understanding and really enhancing their experience and knowledge of key subjects across the curriculum. I had a background before in software project management and I've worked as an analyst for international companies across the world and have traveled quite widely. I have been a mentor as well and an SME for hackathons, particularly for Data Ethics for All and Hackmakers. And I'm a member of the leadership team as well with Data Ethics for All, and responsible for working with the content team to write and curate original articles on our blog and our community, specifically focusing on artificial intelligence, data ethics and technology. I just wanted to first of all introduce some key concepts as well around natural language processing, and then we'll just have a look at natural language understanding, some applications of NLP, and also just talk about a little bit around NLP security, privacy and ethics, and some of the risks associated with NLP, because I'm currently writing a paper on that in that space with Pamela Gupta, and then I'm going to look at language models as well and what we mean by BERT and its significance, and then just finish off by looking at the natural language generation or NLG developments, particularly GTP3, and where NLP fits in the machine learning ecosystem, and a little bit on supervised learning. Okay, so the key concepts for machine learning and particularly for NLP range from, again, NLP, NLG, and NLU, tokenization and stemming, as well as lemmatization. At a very high level, natural language understanding and natural language generation are just subsets or components of natural language processing, okay? And we can see here the definitions of those three concepts. Now, tokenization in natural language processing is actually a process of dividing up texts in key sentences into smaller chunks. And you can see an example here. And essentially it's around filtering, tokenizing, and then grouping key parts of a sentence and then getting those results. It's a really fundamental step as well in both traditional NLP methods like count vectorizers and advanced deep learning. And then we have stemming as well. So after you've actually split sentences up into those key fundamental components and words, tokenization as we call it, we then have to reduce those words to their base or their root form. And this is where sometimes a background in linguistics and languages really helps, because that is something that we are taught in both grammar and the structure of language. But what do we mean by that? Well, it's essentially what stemming is, okay? It's going back to the roots and the base form of a particular word. It's a technique or a method of reducing words right down to their stem or their root form, as you can see here. Computerizing computer, the stemmer algorithm would generate the keyword compute, the verb compute. Okay, you can see them. Then we have lemmatization as well. And lemmatization in NLP is the process through which several different forms of the same word are mapped to one single form, which we can call the root form or the base form. And we can see here a demonstration of that here with the words consign, consigned, consigning, and consignment. We have the stemming process on the left, where you have a stem filter applied, and then lemmatization, which is looking at parts of speech, tagging those parts of speech, and then the lemmas being categorized then just underneath. You can also see as well just how broadly how deep the applications go when it comes to natural language processing and how many groups there are. So I found this visual really useful. There's 3 key groups for deep applications of NLP. Okay, and we've just talked a little bit briefly about lemmatization, stemming, and tokenization or cleanup. But actually, NLP can be applied to speech tagging and parts of speech tagging, as well as query text and query expansion, parsing, topic segmentation and recognition, as well as looking at morphological segmentation of words and sentences. And then it expands to information retrieval and extraction, relationship extraction, as well as word sense disambiguation. Okay, and broadly, we can then go into machine translation, which is in group 3, okay, and natural language generation, which we will talk about very quickly towards the end, where we talk about GTP3, and full generation of text, human-like generation of text. And in group 3, you also have reasoning and knowledge-based responses to NLP, to questions in NLP applications, which I will also briefly go over in a little while. Okay, so then we look at as well the groupings, and I think this is really important when it comes to NLU and NLP. Within this particular this graphic, you have then the NLP and NLU overlaps, and then what is outside of that traditionally. So text-to-speech and automatic speech recognition sit outside of, would you believe, NLP and NLU, but within that space, you have some overlap. So question answering, for example, is actually partially NLP and partially NLU. But semantic parsing and sentiment analysis is actually linked to natural language understanding, okay, as is building a dialogue agent, such as a chatbot, and actually asking questions of an NLP chatbot. Okay, NLP is very specifically about tagging parts of speech, text categorization, and machine translation, translating large text corpora into other languages instantaneously. Okay, so they're the groupings of both of those. Okay, so let's just move on to our next section. You can see as well the overlap here when it comes to NLP with machine learning and deep learning, okay, and AI. Within the middle, you have translation software, so machine learning and NLP overlap when it comes to translation software. Chatbots, particularly the ones that we build, that I'm building with my quizzical chatbot project, is again an overlap between artificial intelligence and machine learning and NLP. Okay. So NLP occurs when our computers read and transform input text into structured data, because that's essentially what the aim is with NLP. It evolved from computational linguistics and uses methods from various disciplines, for example, computer science, artificial intelligence, languages, linguistics, and data sciences. It enables computers to understand human language in both written form and verbal form, because as you know yourself, if you've seen the applications of NLP, and the inputs from us as users is often either written or verbal or audio. Computational linguistics has more of a focus on the aspects of language, and natural language processing emphasizes its use of machine learning and deep learning techniques. And natural language processing works by taking unstructured data and converting it to structured data. And that's where the deep learning applications and the models come into to task. And it does allow us to build translation models and answer questions and pose questions to chatbots, for example. What NLP does is allows us to identify entities, named entities, or name entity recognition, and allows us to see patterns and develop patterns in words using tokenization and stemming and lemmatization. Okay, so a suffix, for example, ed on a word like cold indicates past tense, but it has the same base or root form as we talked about, which is call. We also it'd be worth as well just talking about Markov chains as well, and the hidden Markov chains that are used in the application, in NLP applications, and also in this process. And you can see here an example of how a particular sentence would be broken down into both its subparts. So you have the pronoun verb, and then you have other examples of adjectives, nouns, and adverbs, for example. So hidden Markov chains will come up again later on. RNNs, or recurrent neural networks, actually help to generate the appropriate sequencing of text that we need in natural language processing. N-grams, for example, with a simple language model, or LM, assign probabilities to sentences and phrases to predict the accuracy of a response. And these techniques work together to support popular technologies, as I said, such as chatbots or speech recognition products like Amazon's Alexa or Apple's Siri. Its application's been quite broad, and it affects huge numbers of companies now. It's a growing industry, billion-dollar industry, and is particularly useful in the healthcare and education sector, and also we've seen in banking and services as well. There are many wider applications of NLP, particularly in the no-code and low-code AI space, and I have actually delivered a number of different talks and boot camps on this with Data Ethics for All and Business School of AI. You've already seen that, for example, Google do have their own, both the NLP building tools on their cloud platform using auto machine learning on GCP. They also have their own in-home IoT devices as well, such as the Alexa device. And then you have obviously wider applications of no-code NLP here. And you have the top left, which is just showing you some other examples of chatbots, for example. Okay, so to what extent are companies now they're considering the importance of NLP and actually investing money in developing natural language processing applications? Are they deploying NLP in the most appropriate way, in the most secure, privacy-focused and ethical way? Because as we develop natural language processing tools for customer service and for delivering some better services to users and clients, concerns around security and privacy and ethics do arise, as do the risks around data not necessarily being secured on IoT devices, and also where they are stored, and users' personal data, whether that's voice, text, or video, in a lot of examples, is not always secured, and that's something that we are currently looking at and researching. We're not aware of it often as users. Companies are often not aware that they have responsibilities to comply with legislation, such as GDPR and the California Consumer Protection, Data Protection Laws, and data protection in the UK. And it's a bit of a minefield at the moment, but we are looking at how companies can become more compliant and privacy and ethics and security focused in this space. We know that implicitly as well, when it comes to natural language processing, because we're talking about training machine learning algorithms, that often it's linked to corpora and text. And we know from reading and research around this topic that there is implicit bias in NLP applications, and there are ethical considerations to think about as well, particularly in training data, whether that's historical bias in text corpora or in current data sets. We need to be aware of the ethics of design as well, and actually iron out these unconscious and cognitive biases in corpora and text data, and particularly be aware of the issue around language bias as well when it comes to minority languages. There are not just risks when it comes to data, but also risks around it not being a model for, if you like, representing an increasingly global world. We talk about it being not really focused on particularly the global south, and that there's implications for individuals who don't fit the typical European Western language model. And that is something in terms of the gap and the knowledge that we don't have that we need to consider moving forward when it comes to developing better applications. So context is really important. The geographic reach is really key, and we need to make sure that we keep that in the back of our minds and when we're developing natural language applications and models. Okay, so the next part really is to think about, well, what are we, when we talk about natural language processing, we're actually talking about models as well, and the significance of models in the NLP. One of the things I wanted to just very quickly talk about is BERT, okay, which is a model that we use in natural language processing. And you can see an overview of this particular model here in pre-training and fine-tuning. What is BERT? Well, BERT actually stands for bidirectional encoder representations from transformers. And it's a language model that was actually published and developed by engineers and data scientists in 2018. And it's a computational model that essentially converts words into numbers. And this is the really crucial part for NLP, because machine learning models take numbers in, not words, as inputs. And this is a key step in that process. So it's an algorithm. Okay, it's an algorithm that converts words into numbers to allow the training to be performed in the machine learning model on your original textual data. Okay. The key benefit of having BERT is it's actually pre-trained on an absurd amount of data. And the original BERT model actually came in two, would you believe, significant sizes. So BERT-based trained models were initially trained on over 800 million words or books. And the BERT large model was trained on the full volume of the English version of Wikipedia, which is around 2,500 million words. And because BERT was pre-trained so well, it's actually been applied across not just large volumes of data, big data, but also small data sets. And it still performs very, very well. And there's no real need to fine tune the model. And it's very useful when it comes to building machine learning around natural language applications such as Q&A chatbots. The other benefit of BERT is that it's able to account for words in context, and previous methods of word embedding would return the same vector for a word no matter how it was used, while BERT returns different vectors for the same word depending on the words around it. So that's one of the key benefits of that it's able to put words in context rather than return the same word, okay, on the same vector. The next bit really is to understand now we've looked at natural language processing and the keywords and what we mean by BERT and the model behind the algorithm, natural language understanding. And that really is the next thing. And that is really, and the implication when it comes to NLU is that it's actually about comprehending textual and statistical information captured by computers, okay? The natural language understanding is a subset, as you know, of NLP, which uses syntactic and semantic analysis of text and speech to determine meaning within a given sentence. The syntax refers to the grammatical structure of the sentence, as you may know, while semantics alludes to the implied meaning of a sentence as well. So this is where NLU is, this is the area in which we work when it comes to NLU. NLU also establishes a relevant ontology as well when it comes to data structure, which specifies the relationships between words and phrases, which we have seen before in those previous slides. While humans naturally have conversations with one another and know the structure of language and parts of speech, actually machines unfortunately can't do the same and can't replicate that in the same way when it comes to these particular language models. And it's the combination of these factors, these analyses, that is required for a machine to actually understand the intended meaning of different texts, okay? Our ability to distinguish between homonyms and homophones illustrates the nuances of language well. So for example, if we take two sentences, Alice is swimming against the current and the current version of the report is in the folder. In the first sentence, the word current is a noun. The verb that precedes it, swimming, provides additional context to the reader, allowing us to conclude that we are referring to the flow of water. And the second sentence uses the word current, but as an adjective, okay? The noun it describes, version, okay, is really denoting multiple iterations of a report. Okay, so that's really important to understand. And it's the ability for us to distinguish between those two that is key, and that's what machine learning really also has to try and grapple with. These approaches are also commonly used in data mining as well when it comes to understanding consumer attitudes, in particular sentiment analysis, and allowing companies to monitor customer feedback on their products and services. And they can then track that score, clustering positive and negative social media comments. And then we have finally natural language generation, which is when computers transform structured data into text and compose data in human language. It's the process of producing human language text responses based on some data input. The text can also be then converted into a speech format through text-to-speech services. It encompasses text summarization capabilities, the generation of full summaries of texts from data, from corpora of data or documents that are being inputted. It also involves the ability to extract summaries of key points analysis. So you can actually enable it to take extractive summaries from text as well. And over time, natural language generations have evolved quite significantly with the application, as I said, of before those Markov chains and recurrent neural networks and transformers, which enables it to be more dynamic and generate text in real time. One example that we see quite a lot of in the theory and literature and articles is natural language generation, or GPT-3. Now, GPT-3 is a generative pre-trained transformer, and it's an autoregressive language model that uses deep learning as well. And it produces very close human-like text. And it's actually the third generation prediction, language prediction model in the GPT-N series 3. It's actually a model that was developed by an AI research lab called OpenAI in San Francisco. And some of the key things you can achieve with GPT-3 are translation, application design, coding. It actually generates code for you, text-related tasks and summarization, and generation of new ideas and content, complete generation of new ideas and content. Okay, and we are nearly coming to the end of the presentation. Now, NLP, if as an approach, the question is, well, where does it fit into the ecosystem? And you can see here that we have just a quick overview of the machine learning model, and where NLP really sits when it comes to that, here in this particular diagram. Now, the other thing that we need to be aware of as well when we talk about natural language processing is that it focuses on supervised learning, and knowing supervised learning or what supervised learning means will really help with your understanding of natural language processing. In supervised learning, you train your machine using data which is labeled, data that is already tagged with the correct answer. And a supervised learning algorithm learns from that labeled training data and helps you predict outcomes from unforeseen data. Okay. And that allows us to then successfully build, scale, and deploy accurate supervised machine learning models. And naturally, this takes time and investment and requires a full body of expertise in data sciences to deploy accurately. And supervised learning allows you to connect data or produce a data output from previous experience, allowing you to optimize performance criteria. Okay, it's absolutely fundamental. And it helps you to solve various real-world computation problems. And here is just a very quick overview of a supervised learning pipeline and the steps involved in that. Here we have an overview of the classical NLP model and deep learning-based NLP, which I think is quite a nice distinction and quite a useful summary as well, where you have the documentation input, language detection, the pre-processing, modeling, and output stages in the classical model, and then in the deep learning model, you have the documentation, pre-processing, and then the dense embeddings with hidden layers, and then the output units and the output here. And the output for both is sentiment, classification, entity extraction, translation, and topic modeling. Okay. Thank you very much for joining me on this particular 20-minute NLP introduction and talk. You can connect with me on these links below. I have been doing a lot of reading around this particular topic, and I'm continuing to work on research in the ethics and privacy and security of NLP. So I would definitely recommend looking at IBM's blog website, for example, and some really useful resources in this space are here in Towards Data Science and Guru 99. Thank you very much and take care.